Welcome back, everyone. So we are going to start with going through the homework that you just submitted this time. So we are just going to go through the homework. Did you have fun doing the first question?
Not really.
What's the name of the first theorem? Really?
It's called Goldbach's conjecture.
Okay, Goldbach's conjecture. Can someone tell me whether this has been solved or not? Is it? No. Oh. What's the name of the second one? 1B? Olivia?
Twin prime conjecture.
Twin prime conjecture.
There's another name for it.
Isaac, has it been solved?
No.
No. But someone made a lot of progress in the last couple of years. What's the name of the mathematician? Does anyone remember?
What about Terence Tao?
He also made some progress, but it's after the breakthrough kind of made by this other mathematician. The third one, what's the third one? Really?
Fermat's last theorem.
Okay. So it's Fermat's last theorem. Has this one been solved? Naomi?
Yes.
Yes. So not this class, but next class we are going to learn a theorem called Fermat's little theorem. So remember when I learned this, there's a joke about had Fermat not written this theorem, probably we wouldn't have the word little here. It's because he made this theorem that became so famous for hundreds of years. So this other theorem is now known as the little theorem. I don't know whether that's true or not, but that's what I remember when I learned this. So let's go through a couple of homework. So the first one, 1215. I'm going to show two different ways of doing this, and you need to tell me which of the two ways did you do it, okay? So I'm trying to find the factors of this. So the way I do it is, first of all, it's divisible by 1, okay? It's not divisible by 2. Is it divisible by 3? 1 plus 2 plus 1 plus 5 is equal to 9. So it is divisible by 3. Is it divisible by 4? 5?
No. Yes.
What about 6?
No.
We don't have to try because 2 and 3. It has to be divisible by 2 and 3, right? For it to be divisible by 6. Well, 7? You basically 7, you have to try it, okay? Try 7, it doesn't work. 8, we don't have to try because it is not even divisible by 4. What about 9?
Yes. Yes.
Because sum of the digit is 9. 10, we don't have to try it. 11, do you remember what we learned about divisibility by 11?
Yes and no.
Yeah, so 1 plus 1 minus 5, so it's not. 12, again, we don't have to try it because it's not even divisible by 4. Are you with me? Because for it to be divisible by 12, it has to be divisible by 3 and 4. So given it's not even divisible by 4, it's not an even number, I'll skip it. 13, we can skip. So you should try it, but 13 is not. 14 is not even divisible by 7, so we skip it. 15, I don't have to try it. If it's divisible by 3 and 5, so it's 15. 16, we can skip. 17, you try it. 18, do we have to try 18? No?
No.
Okay. 19, we need to try it. Okay, but it's not.
So,
And then 20, we can skip it. 21, we can skip it because it's not divisible by 7, so it can't be divisible by 21. What is it? 21, 22,
the
23,
remaining one is
24,
27.
25. Yeah, so the last one is 3 times 9. That's 27. And you should stop trying now because after you try a couple, you know the square root of 1215 is roughly 35, I believe. Yeah, roughly 35. So after that, you can stop. So this is one way of doing it, and obviously you need to do the division to try the factors. But there's one other part of this question that we asked to do is prime factorization. And prime, do you have a question?
I have a comment.
Okay.
You don't really need to try so many primes if you do the prime factorization, because then you know all the prime factors already.
Yeah, that's the second method that I was going to go through. So 1215, if you write it into a prime factorization, first of all, when you look at this, you should immediately know it is divisible by 3 and 5. Okay. The reason is the sum of this digit is 9. So it's equal to 3 times 405. And then you want to do 3 again. It would be this. And then you do 3 again. And then you do 3 again. And then you do 3 again. And then how many factors does this number have? Daisy? Rafi? 12 is 5 plus 1. And then multiply 1 plus 1. So it's equal to 12. Okay. And we should basically do this. And then you can basically write it down. 1215. This is 405. And then this one is 245. This one should be 13 something. 135. 81. And then finally this 45. So you got all the 12 factors here. So these are the 3 elements that we are asked to do. I want to get a show of hands who started with the prime factorization when you did these questions. Who started with this? Okay, good. So that's the question of 2b. 2c is a lot longer because it has more factors. But if you started off with the prime factorization, you should basically know that there are 4 t factors, 40. So then you basically need to identify the 20 smaller one, and then the other 20 will be on the right hand side. So let's go through the question of 3a and 3b, and this is more important because the class today, we will need to go back to the answer to those two questions. So because of that, I recommend you kind of write down this part. Okay, so we're going to do the 3a. So it is basically the answer to these 2 questions. So the first one is find the GCD of 228 and 28 using the Euclidean algorithm. Can I get a show of hands when you did this homework? How easy or difficult was this question to you? Okay, so good. So this is, in that case, I'm going to make it fast. So this is what is called the Euclidean algorithm. Again, basically it's a fancy way of saying we divide it by 28, but then we have a remainder of 4. And then after that, we take the 28 and then divide it by the remainder. So when you do this arithmetic, it will be good if you just kind of mentally remember why you're doing this. You're trying to divide A by B, and then if there's a remainder, you try to divide it by R. And then if you had another remainder, which in this case we do not, then you divide the remainder R by the remainder here. So you basically keep chopping it up until you can divide. Now, so look at this equation. So I'm going to do this rearrangement of this, which will be used and important in this class. So I'm just going to move this to the left hand side. So I will have something like minus 8 times 28 plus 228 equal 4. Okay. Just kind of mark this, okay? Later on in this class, we are going to go back to this equation. So let's go through another one, which is 3b. This one is GCD of two larger number, 2640 and 1215. Okay. This is going to be similar. So we have 2640 is equal to 1215 times 2. Maybe let's not cheat, let's do it together. So this is 2430, and what's the remainder? 2430, so it's 210. And now we divide this by this. 1215 to 10. I think it's going to be 5, because 5 then it is 1050, really?
I thought that was 3C.
This is 3C? Okay, then you probably right. I'll change it to 3C. So times 5, 1050, so the remainder is 165. To 10, 165, this is 1, and the remainder should be 45. And then 165 is equal to 45 times 3, 135. 135, so this is 30. 45 is equal to 30 times 1 plus 15. And then finally 30 is 15, 2. So I forgot to ask the important question. So after we did all this, and after we did all this, what's the GCD? Olivia?
15.
15. And in this case is 4. Again, we will go back to this later on in class. Okay, but I hope like this is everyone still have fresh memory, because we had a class last week, so it should be something that we just did in the last few days. Any questions about the homework?